Welcome to the physics classroom. We're going to be covering the work and energy unit, Mops 8, where it talks about energy conservation and math analysis. And you need to know and be able to add and subtract and know that the potential energy is equal to the mass times the acceleration due to gravity. Mops uses the value of the acceleration of gravity as 10 and the height, so mgh, and the kinetic energy formula is 1/2 mv squared. And you also need to know that they will add up to the total amount of mechanical energy, and that mechanical energy is conserved. So it's the potential energy plus the kinetic energy equals the mechanical energy, and work can add or subtract from the amount of total mechanical energy. In this problem, it says the path of a roller coaster car coasting along a track is shown in the diagram below. Frictional forces can be assumed to be negligible. In other words, energy is conserved. Perform an energy analysis and fill in all the blanks. Okay, guys, this is really actually easy. If energy is conserved, you're going to have the same total amount of mechanical energy here as mechanical energy here. Notice that 450,000 plus 50,000 is going to equal a total of 500,000. So this is going to add up to 500,000. 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 And this is going to add up to 500,000. Now this seems scary, but keep in mind, is there any potential energy here? No, it's at a level playing field. So the total amount of potential energy is going to be equal to zero, and the kinetic energy is going to be equal to the maximum amount of energy available. Likewise, you see this situation here? The situation here is the same as this situation here. Okay, so you'll have a couple roller coaster problems in this Mops. Next, you're going to have a projectile motion problem. Use the same information that you knew from projectile motion to help you solve this problem. So even though it's at an angle here, you've got a total amount of kinetic energy of 14 joules and a potential energy of 0. Here, keep in mind projectile motion. You have a maximum amount of potential energy here. That means that you're going to have a little bit of kinetic energy here. Okay? Keep in mind that if it wasn't moving in the x direction, the kinetic energy would be 0. And remember that these things are symmetrical. So the total amount of kinetic energy on this side, or total amount of energy in this situation on this side, is going to be equal to the total amount of energy situation on this side. Likewise, B and D will be similar, but not exactly the same. So you can use your knowledge of projectile motion to help you solve that problem. Next, a roller coaster problem with a little bit more math. Here's the deal. You can totally do this because the path of a roller coaster car across the track is shown in the diagram below. Frictional forces can assume to be negligible. Use G equals 10 meters per second to perform an energy analysis and fill in all the blanks. Here's the given. The given is the mass, the height, and the speed. So at point A, you know that there is no kinetic energy because there's no speed. And those numbers are going to give you the total amount of potential energy, which is equal to the total amount of mechanical energy. Okay, so you need to know the total amount of energy from here. Here, you know the height, so you've decreased in height, so it means you've decreased in potential energy. So the potential energy is not going to be the max, but if you know the max amount of potential energy, and you can calculate the potential energy at this height, you can subtract the mechanical energy from the, or excuse me, take the mechanical energy, subtract the potential energy from it, and you're going to get the kinetic energy. Here, you know that the potential energy is going to be 0. The kinetic energy is going to be its max. Here, you also know the height, so you can find out the potential energy, and from that, you can subtract mechanical energy from potential energy to give you the kinetic energy. Here, you also know the height, and here it's just asking for the velocity. So you're going to use the formula kinetic energy equals 1/2 mv squared. You already know the mass because that was given to you in the problem. And you know the amount of kinetic energy is going to be the maximum amount of kinetic energy. So you can use algebra to solve for what the velocity will be. And those 3 types of questions cycle through this Mops for the energy and conservation model. So again, you're going to be able to solve it pretty quickly and easily. Please let me know in the comment section whether this is helpful or if I'm speaking too fast or if I need to write down the formulas on the front screen. Thank you.